The brainstorming stage allows the user to illustrate all of his ideas and organize all of his thoughts. One of the first parts of the brainstorming stage is identifying all of the different requirements of the project. The requirements of the project are the different conditions that must be met in order to achieve the project's objective. By clearly defining these early on in the project, the user will be able to get a better idea of what exactly the project entails and how long it will take to develop. The next part of the brainstorming stage is to express any ideas you might have about the project. The important part here is just to express everything that comes to mind, no matter how unfeasible it may seem. Some of the most innovative and successful ideas have come from seemingly obscure thoughts. After you express all of your ideas, you are going to want to look at any problems that may arise throughout the project. These can be anything from actual functional restrictions to time and monetary restrictions. By listing any potential problems that may arise, the user will eliminate any surprises that may happen down the road. Finally, if working with a group, it is a good idea to have all group members participate in the brainstorming stage. This way, all the group members are on the same page and everyone's ideas can be expressed and organized. Another important part of the brainstorming stage is identifying all the inputs and outputs of the program. The inputs are essentially the raw data that is given to the program from an outside source. This can include user inputs, external measurements, and any defined constants. The program will take these inputs, manipulate them, and then create outputs. To better express this idea, imagine a simple ticket machine that sells tickets for a train line. Some of the inputs for such a system would include the price of the ticket, any customer information, the train schedule, and so on. The ticket machine program would take these inputs, manipulate them, and then produce a user with outputs, in this case the train ticket and any appropriate change. When it comes time to actually program, there are going to be a few important coding conventions to follow. First off, it is important to document one's code. This is beneficial for many reasons. With documented code, others can read it quickly and understand what the program's intent is. In addition, when the program becomes more complex, the original author can look at different parts of the code and easily navigate between different parts. The second part of writing good code is making sure that the spacing and formatting is visually appealing. Make it so that it is intuitive as possible. Also, make sure that any variable names are relevant to what the variables actually represent. If the variable represents the cost of a ticket, for example, call the variable something like ticket cost. It is a good idea to avoid one-letter names such as I or J, as these are somewhat ambiguous and not very intuitive. One of the final and most critical stages of software development is the verification stage. During this stage, the programmer performs a series of extensive tests and use cases to verify that the program is error and bug-free. Another thing to test for in this stage is how the program handles invalid inputs. Think of a simple ATM program. Say the user withdraws a negative amount of money. Obviously, the program wouldn't want to credit more money to the account. An error should be displayed. Tests like these should be performed during the verification stage. Now that you have a basic understanding of the software design process, let's look at a simple implementation using LabVIEW. In this tutorial, we will create a simple program that takes two numbers and returns a sum. From the LabVIEW Getting Started menu, go ahead and create a blank VI. Right now, let's just look at the front panel. On the front panel, we're going to want to put a slider control. Name this control number 1. Next, we're going to want to create another slider control. An easy way to do this, if there's already one control on the front panel, is to highlight the original object, hold down the control key on the keyboard, and drag the object to a different location on the front panel. This creates a copy of the control without having to go to the controls palette. Next, let's create an indicator. For this example, we will use a tank indicator. Let's name this sum. Now that we're done with the front panel, let's look at the block diagram. For the sake of this example, let's just go ahead and wire up the block diagram as it is right now and not move around any of the elements. First, let's add an add function to the block diagram. Next, let's wire it up. As you can see, this is not a very intuitive way to wire up the block diagram. None of the wires are going the right way. Number 2 is going from right to left, which is not intuitive. And overall, the elements are just placed in confusing places. Let's arrange the items so it's a little bit more intuitive. One way to clean up the wire is to right-click the wire and go to Clean Up Wire. Next, let's add documentation. Documentation can be added by double-clicking anywhere on the block diagram where there is not another element or wire. As you can see, this program is a lot more intuitive than the first way the block diagram was wired up. All the wires are going in the right direction, there's documentation, and it's just very intuitive and easy to read. Now, let's actually try running the program. Let's put values in the 2 numerical controls. And let's hit run. As you can see, the program takes the sum of the 2 numbers and displays it on the tank indicator.